alpha and beta. Let's just call them two. So we already used up x and we used up ABC, so we'll use alpha and beta. So
wait, I feel bad for D, E, and F. They never did.
I know, yeah. Well, E does get used, and it's a constant, so we don't do that. D and F get used a bit, but F and T, it's...
Remember like T?
Never seen T? Yeah. People, T is used a lot in kinematics, so time, physics, yeah. All right, so roots, remember, bang, bang, these are roots of an equation. Okay, so we're doing this for all roots. If we knew the roots of the equation and we wanted to go back and form this, we would use probably the intercept form, this x minus p1, so we'd have a x minus alpha now, and x minus beta, yeah? Does that make sense? So we, in general, like if we knew it was 3 and 4, we'd just put in 3 and 4 here, but this is for every single one. So we're just saying alpha, beta. If you're working backwards, we'd use this form. You look confused.
Yeah. Even if that's all you know?
Yeah, if I said, okay, and how did you do the ones for homework when you had, oh, you're given a diagram, the roots of the equation are 4 and minus 1, what did you do?
We had the y-intercept. Yeah, we had the y-intercept.
Oh, you had a y-intercept. Yeah, you had some other piece of information. Yeah, you had a y-intercept or another. So you went, oh, I'll use this form, x minus p, x minus q, and I'll put in for p and q, and also same thing, exact same. Except for this one, I'm just saying in general the roots are alpha, beta, not we have specific ones anymore. Okay, and I know when I multiply that out, I'll get some quadratic. Correct?
Yeah. We should be writing this down.
You can. You write the conclusion down if you want to take anything else. Just watch for now. Okay. So in a kind of like equality kind of way, I want to start multiplying this out to see what happens. I'll leave the a till later. I'll multiply my brackets because I'll get x squared minus alpha x minus beta x plus alpha beta. Yeah? And that still equals all this.
Wait, what's the sign for alpha?
What does it look like? It's like, it looks a bit like a, remember? Yeah, fish without the tail. It looks a bit like the proportion one, a little bit. But just try and draw an A, and then, I don't know. Okay. So I'm trying to equate both sides. I'm trying to get an answer for some way of equating both sides, so I can look at the x's together, the constants together, and stuff like that. So what I'm going to do is I'm going to divide both sides by a, because multiplying all this by a is going to be a bit of a mess. And I'm also going to combine these two into one at the same time. So maybe I'll do this side dividing by a first. That gives x squared plus b over ax plus c over a. Yep? Yeah, that's very useful. Oh, that's okay. Yep.
So you're just saying if you have two roots, and you show how to find those two roots?
In general, what relationship the two roots, I'm looking at, in general, what relationship the two roots have to the original equation.
Are you going to is it going to end up with a quadratic formula again?
No. It'll just end up for something to do with the sum of the roots and the product of the roots. That's all we're going to find out. The sum of the roots of every quadratic and the product of the roots. The sum of these two, if we add them together, alpha plus beta, and the product, alpha beta. Sum is add, product is multiply. And maybe you can see that already coming together here. So if I divide this by a, well, that's fine. If it just becomes, the a's cancel, yeah? So if this step is divide by a, everything. Putting these two together, I'm going to put the negative outside the bracket, and can we see an alpha plus beta here, x? If I factor out a negative out of both of these, here, that these two combine to form this. If I factor out a minus 1, I'm left with alpha plus beta, and then the x comes out, or factor out minus x, if you will.
I'm so sorry, but I just don't
Yeah.
understand anymore. He's saying you're just X.
So I have minus alpha x minus beta x. If I want to factor out this, if I factor out the minus first, I left with ax plus bx, yeah? And then if I factor out the x, but actually write it afterwards, like that, I factor out the x on the other side. So I could have factored out minus x in front if I want. I just put it after. It does. It is just a factorization.
And so you did the same thing for x squared and...
Oh, where did this a go?
No.
Yeah.
You're doing the same thing.
I didn't do anything for this. Didn't do anything for that. And I divided all these by a, because that's what I said the step was, divide everything by a. And already I can make a statement about the sum and the product of the roots. So remember, sum of the roots is alpha plus beta. What can I say alpha beta is? The sum of the roots of a quadratic are alpha plus beta, the sum, sorry, I put an arrow there, equals what? I'm making an equivalent statement between those two. The x squareds are already lined up. The coefficients of x squared, the left-hand side must equal the right-hand side. What's alpha plus beta equal to on this side? Minus b over a. Yeah. And what's? Because alpha plus beta is here, but it's negative alpha plus beta. So if I want what positive alpha plus beta is equal to, it'll be the negative of this. Because the x coefficient must line up because they're equal each other. There's nothing to change the x coefficient anymore. There's no more multiplications to be done. And the constant has to equal this. That has to equal that. So the product of the roots. This is a proof. Alpha times beta is always c divided by a. The product of the roots is always this c divided by a.
Divided by a always equals the roots multiplied.
The y-intercept divided by a. Yeah. Notice the coefficient. We've made the coefficient of x squared 1 for this. So if your quadratic starts with a 3x squared plus 4x plus 7, this might be a bad example, but if it was this one, the first thing you do would be to, well, what's the product of these roots?
Wait, can anything be quadratic? Can you just write down any set of numbers?
Yeah, well, yes, anything can be quadratic, but it may not have roots. If I'm, some of them miss, some of them hit the x-axis. And we look at the fact that all of them will fit the product and sum of roots, yet some of them mightn't have any roots, any real roots. And that is the first question that we answer when we start with complex numbers. Okay, what's the product of these roots? So we just go, product of roots is the c divided by a.
What is product?
Multiply. Product means to multiply. Two roots, so two numbers multiplied together.
7 and 2 is 14.
Yes, the product of 7 and 2 is 14, but that's not.
7 over 3. But if you have, isn't there like infinite products?
We have the products of the specific roots of every quadratic equation will be its c term divided by its a term. The two roots, when you do find them, will be the c term divided by the a term, multiplied, which you kind of do anyway when you factorize. I don't know if you thought about that. If the c term, it just so happens to be 6. When you find the roots, they're 3 and 2. And 6 divided by 1 is 3 times 2. If you did this, 3 and 2, and the roots are minus 2 and minus 3. When I multiply these two together, I get 6 again. But we already knew that because 6 divided by, you already do it anyway.
Okay.
But there's this terminology that will help us work backwards when you're given just the sum and the product. We can work backwards now. Yes?
Isn't the sum of roots also the z-axis symmetrical?
That'd be minus b over 2a.
Yeah, but
When you add the two roots,
isn't it just the average?
yeah, no, it's these are just adding the two roots, not adding the two roots and dividing by 2.
Oh,
Yes, you've just added them. Yes, you're on the right track. Yeah, it's very close to the axis symmetry. You just before you divide it by 2. So the product of these roots would be 7 over 3. I know that before I even start, and the sum of these roots is negative b, which is negative 4 over 3 of this one, based off this. So this is something that comes up a little bit, and we'll be dealing with a little bit more when it comes to complex numbers and polynomials, longer polynomials later on. But that's just a starting point. That will come up in this exam, and only related to quadratics. The other thing that will come up